Hello, welcome to another episode of TGIK. This is episode 14, so I guess I've been doing this a while now. I'm getting it figured out. If everybody, quick sound check, can everybody hear me? Everything sounding good? I can see my face. I don't know if you can. But welcome. I'm not doing beer today, I'm doing LaCroix. It turns out that you start a startup and get a fridge and magically the LaCroix just appears. It's kind of amazing. It just spontaneously creates. So Alex, welcome. Good to see you. So so today we're going to be covering a few things like all things Kubernetes. And then we're going to be spending some time looking at OpenFaaS. FaaS? I don't know, function as a service, open function as a service, which is another serverless framework for Kubernetes. This one has been around for a while and it works in other contexts outside of Kubernetes. And so we're going to take a look at that, get started. I generally look a little bit under the covers to see how is it using Kubernetes, what sort of stuff is installing, what to expect a little bit there. FaaS, F-A-Z, Alex says. And there's some other contributors around also. Great. And Hal from Florida, nice to see you. And so going to be going into a little bit there. And then I think we can, maybe spend a little bit of time doing some compare and contrast to the two other frameworks that I checked out in the last two episodes, which is kubeless and fission, which are the other two. But usually when I start out with these things, I do a little bit of like announcements, what's new. Folks can ask me some questions and we can actually go through and talk about sort of like what are some new and interesting things that I'm not going to be covering today in the world of Kubernetes. And so with that, Australia, Paul, nice to see you. Super early there. You're living in the future. Let's see. So with that, I think let me switch to my screen. And I want to go through some things that have been going on. Now, some of these things are Heptio specific, so I'll cover those quickly. So the one thing is that every time I've done one of these, I'm using our QuickStart for AWS QuickStart for Kubernetes. This is something that we did early on, and we've been updating it as we go. Richard from New Zealand, and then Ray from Scotland. Nice to see you all. And then Federico Koval, are you speaking IKEA speak? I don't know. Ciao, Ralph. I know you, Ralph. You're not in Italy. You're in San Francisco. Busted you. All right. So so we have so we've been doing this AWS QuickStart, and it's just a single button click to get up and running with AWS. We've updated it for 1.8. And this is something that we're going to work to make sure that we have as much as we can. We support a really easy way to get up and running, and there's all sorts of ways to deploy clusters. This is something that is that we built just to be super easy to. And this is built on top of kubeadm. We've gone through that in the past also. So anyway, so we've updated this to 1.8. Not much has changed in terms of the experience there. So it's pretty much the way that was before, but now it's 1.8. We did fix the issue that I ran into during the kubeless episode where we didn't have a default storage class installed. And so that kind of caught us. So now there is a default storage class by going on there. And so that's good also. So I'm going to be running with a 1.8 cluster today. Hopefully that won't be a problem. I'm going to check it out. I also have a 1.7 cluster in my back pocket so that we can use that if we get stuck. Let's see, other notable things. So we've been doing some interesting open source projects. I think they're interesting here at Heptio. And we, over the last week or so, we've released new versions of a couple of these. And so I want to just go over that real quick. The first one is this project called Sonobuoy. This is a diagnostics thing for Kubernetes. You drop Sonobuoy into your cluster. You let it do its thing, it runs a bunch of tests, and then it generates a report. And then you can use this other service that we provide called Sonobuoy Scanner to essentially, create a nice looking web page around that report. And over time, we're going to make this thing be more interactive. We're going to be running more tests. It's going to actually do more stuff in terms of being able to figure out what's going on with your cluster. This is also used as part of the official conformance effort for Kubernetes. So with the CNCF, we're getting in the position where we can run some tests and say, yes, this is a conformant Kubernetes cluster. And there's a logo to go along with that, and that's based on the work that we've been doing around Sonobuoy. And so there's a 0.9 release here, and it's a better way, now supports the 1.8 end-to-end test, so it's sort of an enhanced conformance test for 1.8, along with better ways to get data back, more logging and configuration, that type of stuff. So a lot of good stuff there, some good bug fixes also. The next thing I want to talk about is Arc. So this is our backup, disaster, and recovery tool for Kubernetes. Now, the Steve and Andy are the ones working on this, and I know that Andy has in his back pocket, he wants to do a blog post, or maybe we can have him on TGIK, and we can talk about what are the different sort of strategies and ways that you can think about backing up your Kubernetes cluster. The way that we do it with Arc is that we actually go through official interfaces, but then we also have integration with cloud providers so that if you're running on Amazon, for example, we'll go through and create EBS snapshots for the right persistent disks to try and capture as much data as we can about your cluster. The interesting thing that I think the big headline for this release is that there's support for backup hooks. And so now what you can do is you can have ways to integrate. Walid, you're in Saudi. Nice to see you again. So there's good ways to integrate your application with this so that as you're doing a backup, your application can make sure that it actually creates the right data, flushes everything to disk, that type of thing. So starting to actually build the connections between what Arc does and what applications need. So that's really exciting. The next thing, and this is something I'm really excited about, and I haven't had a chance to play with it yet. I think maybe next TGIK might be a good time to do that, is this new project, brand new from Microsoft, called Brigade. I'm going to put all these links in the show notes afterwards. Lewis, hi. This is an interesting, Oliver, how's it going? This is an interesting sort of twist and take on some of the serverless stuff. It's in some ways more generic, in other ways more narrow, at least from what I've been reading. I'm really looking forward to getting into it. But basically what it is that you have a script, and that script can, you can trigger that script, and it runs jobs by just saying run containers. These are Kubernetes jobs. And then that script, based on the results of those execution, can then go ahead and run other scripts. And so you can do workflows based on that. But, if we were to compare and contrast this to, say, the fission workflow engine, the fission workflow engine is an explicit DAG, directed acyclic graph, whereas it looks like Brigade is a dynamic DAG. So you can actually change the shape of what you're going to run and how you're going to run it based on the previous data that you got and from earlier runs. And then it also, instead of just doing sort of serverless functions, it goes through and just runs containers. And so those containers can be whatever you want them to do. Really interesting stuff. I'm sure there are ways to integrate this with serverless in a more direct way also. So this is sort of the blog post that goes over it, but there's a whole website, brigade.sh, that talks about this stuff. So Ralph, I hit docs here and it dumps me into a GitHub page. I'm not sure if that's what we want to be doing there. And then I can do index.md and I start getting to something, but that's probably not what you guys want this to be eventually. But then you can, here's how to install the thing. So it looks like there's some really good tutorials and stuff there. So Ralph does documentation stuff at Microsoft, so he's the right guy to complain to about this. So really interesting stuff there. I really want to dig into that. I think that there's one of the things, and we're going to have something more to talk about probably in the coming weeks here, is this is in some ways overlapping with the work that we've been doing at Heptio with KSonnet, right? Because one of the things that I think is interesting here is that instead of using YAML to describe the job that you want to launch, you're using JavaScript to describe it. Oh, my highlight didn't work there, but so here's essentially a simple way to describe a job, right? So you're not actually using YAML. You're having JavaScript, and I assume under the covers, that compiles down into YAML. And that'd be something interesting to dig into there. So part of this is a JavaScript framework for actually creating configs that you're going to go ahead and run. There's different schools of thought in terms of how do you actually sort of build and manage configs. For something like this, I think this is a really interesting solution. I think for other folks, saying, oh, I have to write code to deploy my code, just feels a little bit wacky. And then you have stuff that's sort of at the far end of the extreme, which is Brendan Burns, one of the other co-founders, has this project that he's been playing with called Metapixel. He's been noodling on that for a long time, where the way that you deploy and describe your thing is actually described by the application itself. So the application kind of becomes self-deploying. I think there's pluses and minuses there also. So this is sort of another interesting sort of solution in that space, which I think is really cool. So Lewis from Essex and Austin from Pennsylvania. Good to see you. Let's see. Yeah, so very cool. All right, so with that, it usually takes me like 10 to 15 minutes to cover this stuff. But anybody have any questions about that or other stuff that's actually been going on in the Kubernetes world? I'd be happy to sort of, before we jump into OpenFaaS, to actually talk about what's happening elsewhere. No, nothing. It's all boring. No? All right, people from the UK saying hi to each other. Docker? What about, so I talked about the Docker stuff a little bit last week. I'm still waiting to actually see what you guys are. Oh, wait. Ralph, you're now a PM. Oh, look at that. Okay, so and then Timo's from Germany. Great. Yeah, so Docker and Kubernetes. And then Richard, yeah. So Docker and Kubernetes is a really interesting thing. And we talked about it a little bit last week. I think we're all still waiting to figure out what exactly that looks like. It's not fully public yet. So like I signed up for like, hey, let me know when the beta is ready. A lot of the... if you look at the Moby announcement, a lot of that stuff is starting to integrate things at sort of lower level parts. It's. I think it's still. I know there were some demos. I haven't had time to watch all the videos, but I think there's still some questions in terms of what does the integration look like at the higher levels when you start describing applications, because I think there's very different philosophies with, say, how Swarm and Compose actually view structuring applications versus how we do it with Kubernetes. Kubernetes has a lot sort of more fine-grained primitives that you can put together to do things. It makes it some ways harder to actually get involved and to sort of spin up on this stuff. But I think a lot of people have found that those primitives are incredibly flexible for doing a lot of stuff. Whereas I think Compose is very much more the sort of like 80 or 90% case. And so it's going to be interesting to actually see what happens there. Let's see. Oh, there's the AKS announcement also. So this is, let's see who was saying, Hans was asking about, I guess AKS is AK Steel Holdings, Azure Kubernetes Service. Let's see what that actually gets us. All right, I assume, yeah, here's AKS. So this is the new thing. I haven't had a chance to play with this also because honestly, Azure confuses me. The console, every time I do it, I get confused, but I should probably make time to actually play with that. So that's really cool. Brad gave a talk on Kubernetes cluster security last night. I think I might have seen your slides, Brad. If you you put a link there, unfortunately, I don't think that, let's see if I can GL, I can't see, is that here, I'm going to look down here and copy and paste. P. This is risky here. Okay, is that going to work? Yeah, there we go. So this is interesting also. I saw these slides on our internal Slack, and there's definitely some interesting stuff going in here. And it's something that is, there's a work in progress here where we're over time with each release cranking things down and finding and fixing more problems. I think it's interesting to look at the attack vectors here, but we're definitely improving this stuff over time. So this is definitely something interesting there, and I think it might be a good thing to cover securing Kubernetes and sort of what some of the state of the art is in a TGIK also. So I think that would be a good topic. So I think if you all can see that link there. I wish there was an option that I could do in the YouTube chat to say let people post links, because we haven't had a spam problem with this stuff. People have been really good, and so I know a lot of times as we're having these discussions. So I'll definitely include a pointer to that in the show notes also. Brad. Okay, so let's see. So let's get started. So Lewis is saying, would it be nice to see a QuickStart packs for OpenFaaS and some cloud providers? I know it's trivial to play, but at a certain point, someone will need to package and remove complexity. Yeah. So let's see how complex it is to actually get OpenFaaS up and running here. Reordering my tabs. So Alex, console confusion. Yeah, Ralph. Alex wrote me earlier on Twitter and said that this deployment guide here is probably the right place to start. But there's also a web page with a really pretty image, the tail, and I think it's tossing. Is it juggling the containers? Is that what's going on there? And I think one of the interesting things, and this is a little bit different from OpenFaaS versus other stuff, is that there's guides for deploying on Swarm and integration with some other types of things beyond Kubernetes. And so, so I have not. Yeah, Richard says you can post stuff as long as HTTP isn't missing. Maybe that's the case. All right, so I have not looked at this yet. So we are, there are functions that are being juggled. Okay, little mini containers. So I haven't actually taken a look at this quite yet. So I'm new to this. And so we're going to be going through, okay, Nomad and Cattle are also deployment options, Alex is saying. So I'm going to be going through this for the first time. We already have a cluster up and running. I generally, when I'm doing stuff for the first time and installing it, I really want to dig in and understand what exactly is being deployed to the cluster. And so I'm not going to go with the Helm chart. Instead, I'm going to go ahead and clone. Apparently, there's a repo called Faznetes. Okay, so we're going to go ahead and we're going to clone that and get started. Okay, so that's not that big. That happened fast. And we'll pull up what we got going on here. And it looks like there's a whole bunch of stuff going on here, a bunch of YAML files, tests, types. Oh, wow. So there's actually some code in here. This is sort of, it looks like this is really the adapter between FaaS and Kubernetes. So that looks really interesting too. And let's see. So here's a whole bunch of stuff here. So okay. So it looks like there's some good stuff there. But I'm gonna continue down this guide. And it says deploy a synchronous or asynchronous stack. If you're using OpenFaaS for the first time, we recommend the synchronous stack. The asynchronous stack also includes NAT streaming for queuing. So so this is a question here. Is when you're making a synchronous call and you're installing the asynchronous stack, do the synchronous calls still happen synchronously, or does everything get queued? Is it like a pure queue mode for everything, or is it like synchronous plus async is being like the thing when you install the asynchronous stack? So that's something that I'm wondering. And then there's a note down here that Kafka is available in a PR. I think that it's a super deep. Okay, so it's or. So it's either. Okay, wait. So there are two endpoints. Okay, so you can go through, and so in the async guide, it goes into some detail there. So, all right. Okay, so you can hit them synchronously. That's the synchronous flow, and then the async flow is a lot longer, and you can sort of do a call. Oh, that looks really interesting. Okay, cool. All right, so this is actually, I love state diagrams. These are my favorites, right? A lot of these UML diagrams I think are completely useless. You know, these flow diagrams like this, I love this. So okay, so here, like you go resize image goes to a gateway that calls the function, and then the request gets passed back. I assume it probably goes through the gateway. I don't know, maybe it doesn't. And then asynchronous is more along the lines of you call this stuff, let's see, into the queue. There's a queue worker. It goes through, it does that. And then it's not clear. Like, I think when you do the asynchronous stuff, there's no, like, it's probably just like a 201 accept that you actually get. Yeah, I'm sorry, I'm making fun of UML diagrams. We're going deep here. And then this thing could also call back to a URL, right? Or you could probably drop some stuff in S3 or whatever. Okay, so that's really interesting. So the async work is really sort of put this function call on a queue, but it looks like it's still sort of viewed as a function call. Okay, cool. All right, so we're gonna let's just start with the synchronous stuff, and then we can always blow it away later, and if we have time. So we're going to have 3 files here that we're going to do: FaaS, monitoring, and RBAC. Okay, so FaaS. Okay, so one of the things that, let's see here. So the first thing I'm noticing is that this thing does not pick a namespace to actually deploy itself to. And that's okay. But it means that, like, if on a bare cluster, you're going to deploy it to your default namespace, which you may or may not want to do. So it's something to keep in mind. It's also claiming a node port explicitly so that we actually have a number there. Most of the time, if you can get away with not having an explicit node port, that ends up being good. Okay, namespaces in the Helm chart. Yeah, Helm ends up taking care of the sort of default namespace for you. Let's see. Lewis is closing or we'll get to that, man. We'll get to that, Lewis. We're not there yet. You're jumping ahead. You guys are way ahead of me. And then we have a deployment for the controller. And this thing, we have a image. And so this is stored on the Docker Hub under functions. And then we have the service. Again, we have a different node port for this service for the gateway. And so the gateway then is another container. Let's see, has the functions provider URL. So this is like, okay, who is actually going through, and so this is pointing to FaaSNetties D, which ends up being the controller. Okay. So the controller is also here called the provider, the function provider. So this is the thing that probably provides the super dynamic service discovery for figuring out which function, what the mapping is. Yeah, so node ports are good for getting up and running for newbies. I do like the fact that, like, this stuff is type node port by default, just because, I don't want to open stuff up to the world to begin with. So it's nice to be able to. It's nice to be able to actually get started without that stuff. And then let's see. So, and then monitoring. And what does monitoring look like? So this is going to deploy a Prometheus. It has its own node port. So we have node ports for everything, and that's fine. There's really very little cost for those. And it's using the apps v1 beta 1 for deployments. This stuff is confusing. Nobody understands the apps versus extension stuff. Let's see. And so we're running an alert manager also. Okay, so we got Prometheus going, and then this guy has, okay, and so you guys are shipping your own container with Prometheus that has the YAML file for Prometheus built in into etc prometheus.yaml. This probably makes some fairly hard-coded assumptions about what the services are named. And so if you start mucking with these things too much, my guess is that the Prometheus config will break. Okay, so config maps in a PR to move that stuff out of, yeah, it's, yeah, no, it'll work. It'll work. It just means that you lose a little bit of flexibility when you do that stuff. And then if I look at RBAC here, what do we see? So the FaaS controller has get, list, watch, create, delete, and update to the services resource, to all services across everything, because this is a cluster role. and we're doing a cluster role binding. And then deployments. So essentially, it gets the opportunity to do full management over deployments and services across all of your Kubernetes cluster. So that's we'll definitely check that out and see how that's being used as we go. So yeah, you guys are actually going through the code here. So the alert manageable, at line 31 has a hard-coded namespace default in monitor.yaml. Okay, so with that in mind, like by default, I would actually probably put this in a different namespace, but since Hans says that it actually does have a hard-coded namespace equals default, I'll deploy this into the default namespace for now, just to make sure that things don't break. And I'm not worried about this opening up load balancers to the world or anything. And this particular one is not taking any persistent volumes, and so pretty much everything here is probably stores all its state in Kubernetes directly. And Alex says that we're looking at the batteries included version, and the Helm one has a lot more tweakables. So that's good to know. So we can probably look at, I don't know, the Helm chart. It's probably here somewhere. Yeah, here's monitoring-config. This has a config map with a whole bunch of stuff that you can go ahead and tweak, like how should I send email? Because that's never easy. So we're not going to worry about that. Okay, so we're doing this sort of super duper simple kick the tire stuff. And so it's probably worthwhile saying that this will deploy stuff into your default namespace, or it assumes that you're on your default namespace. So let's go ahead and we'll run this. And look at that, everything worked. Okay, so we got the FaaS NetEasD service with a service account and the deployment behind it. So these guys all do their thing together. We got the gateway service. Does the gateway, I didn't check, does the gateway use the same service account? Let's go ahead and where was it? It would be FaaS.yaml. The gateway doesn't specify a service account. Okay, so it's not doing any sort of Kubernetes interaction, so it'll get the default service account, which on an RBAC cluster by default doesn't have any permissions to really do anything. So that means that thing's pretty locked down, so that's cool. And apparently here's all the Helm chart stuff. Okay, cool. And so we have a lot of stuff that ends up being parameterized here. Yeah, and then the YAML rendering in Visual Studio Code gets confused when you load Helm charts, so that's kind of a pain in the butt. So a lot of stuff going on there. Okay, so cool. All right, so there's a lot more. So here's all the tweakables for the Helm chart. Not too many. You can specify which images you want, whether you want to enable ingress. And you specify the host that you want this thing actually listed as, and then you can specify the ingress class. That's cool. Okay, so we'll play around with maybe setting up ingress for this later. Well, let's get started. Okay, so now we have the thing up and running, and now we can use it. After deploying OpenFaaS, you can start using one of the guides or blog posts to create a serverless function or test the community function. So is there a command line that I need to install? And so this was assuming you're doing Minikube. So now there's an assumption here that I can go ahead and actually get to these things. Okay, and then connecting to the UI. Node ports rather than the ingress controller. If you're advanced Kubernetes user, you can do this stuff. Otherwise, oh, and here, install the URL. So let's go ahead and let's see what this thing actually does. This is determining architecture and then going through and downloading some stuff from GitHub. So that sounds reasonable. So I am going to, oh, I don't like the sudo. This is going to install it into user local bin. All right, so we're going to do this. And then the version, what is version set to? Oh, I have to actually get the latest version. Wait, okay, so this is just going to pull it from releases. So let's just go up here. Oh, not pull requests. Does this have any releases? This is FaaS CLI. Okay, is the 36 releases. And we'll go ahead and so I'm going to rename this to FaaS CLI because we're on Darwin, chmod plus x. Okay, cool. All right, so we got that. And then I can open the UI and yeah, go to the node port. So the problem here is that because we're running on Amazon, it's a little bit tricky for us to open that UI directly. So we got a couple of options here. We could do kube control port forward. Kube control port forward only works with pods, not services or node ports. And so that kind of sucks. The other thing we can do is we can go through and we can do some SSH magic into this thing to actually get access to those ports on the local machine. And so let's go ahead and we're going to do a little bit of SSH magic here. One of the things, there's also kube control proxy, but that does a bunch of sort of, mucking of, it opens one thing and then it essentially does HTTP proxying, which is not what we want really either once we start calling this stuff directly. So here's a command that'll actually SSH us into our master. Could you not expose a node port or add a load balancer? So we could go ahead and add a load. Okay, so this is the question. So Alex, is there any authentication on this thing? Or is it assumed that like, hey, if you can hit the API for this thing, you're actually good to go, right? Because if I went through and exposed the node port, publicly, then I'm gonna have the problem with anybody on the world can actually get to this thing. So that's one of the reasons why I'm a little bit resident, but we can go ahead and let's look at lb.yaml and actually go ahead and check that out. So where is that? All right, so it's under cloud. Okay, and this just changes the service to, this starts a load balancer for the gateway, but it doesn't actually start a load balancer for the controller. And I assume that it's the controller that this thing is going to talk to, unless there's a special, like, I assume that OpenFaaS talks to, I need the gateway. So is the gateway good enough for me to actually get to the UI and install functions and all that stuff? I think that's the question. Well, let's go ahead and we'll do the load balancer thing and we'll just see what the heck we get there. So because this thing actually does say, this does say that, oh yeah, there's the load balancer thing. Okay, but this is up at the top and I really need that when I get down here connecting to the UI. Okay, so the API gateway and the UI are hosted on the same port. Okay, so let's just go ahead. Let's do that and see what happens. So this is under cloud. Okay, kube control apply -f. Now the problem is that I'm running on Amazon and ELBs take for freaking ever to spin up. So we can go ahead and then there's no instructions for users to, like, this is always a crappy thing. Service. So I can do this and like here's all my services here, and you see we have this thing here, but that's not what we really want. So we have to do O wide, and then that gives us this. And if you like do this like funky JSON path thing, you actually get to that. But that thing's actually not up and running yet. But let's do some fun stuff because I have this. Let's go through, and if we look at Route 53, I have I bought TGIK.io. So here we go. And I just do a CNAME of star to whatever my latest load balancer is. So now, if there's no auth, all y'all can start mucking with stuff. So please don't mess me up. So I can do food.tgik.com. Let's see. Oh, not tgik.com, which is available for the low price if I can't afford it. Okay, so this thing, all right, so it's going to take a while for that to actually sort of get its act together. So yeah, name not resolved. So the ELB is not up yet. So let's go through and we'll also play around with the SSH stuff. So everything communicates with the oh, I have to have the port too. Okay, so when I do it, we normally work on regular clusters. Blah, blah, blah. Yeah, but with all those things, you still have this question of like, how do you get access to the thing? And I think more and more people will be running clusters where there's no direct access between you and the nodes on the cluster. I think running this stuff closer to the internet is going to actually be more and more rare over time. So let's see. So this thing. So yeah. So I do need the port, but actually, do I need the port? That's port 8080, okay, is what this thing is running on. I got name not resolved, so it's still, oh, look at that, okay. Create a new function. So node port exposed on a public IP on these clouds, but good point, we can do better. So, okay, so, oh, and okay, look at this. We got the sweet material of like UI here. Look at that, I press it and there's like cool animations and stuff. All right, so the one thing that I think is like my thanks, Antoine. The one thing is that like some semblance of security out the gate here, even if it's just some sort of randomly generated token, would make me feel a lot better. Like I think having to go through and just by default having this stuff open to the world is a little bit scary, especially when you're using the same gateway on the same port for both the UI and the functions that you're going to call, which means that like pretty much anybody who has access to, if I'm not wrong, anybody who has access to any of your functions can install or remove or manage any functions. So that seems to be, there are works to defer security to a formal gateway guardian port. Okay, so yeah, so foo.io, there we go. Okay, so yeah, so I have it mapped to it. So we'll make it look official. We're gonna do OpenFaaS.tgik.io. There we go, okay. All right, so we're cooking with gas now. Okay, so basic auth via the CLI is there, but it's a modular system. Yeah, so this is, I think, one of the interesting things here, and I think we see the same pattern repeat itself with Helm. We see the pattern with the Kubernetes UI itself. We see it with we see the same pattern with Fission, which is anytime when you're running a separate API that's sitting in front of Kubernetes, you end up with an auth problem. Whereas you have auth for your system, and then you have to actually go ahead and then have auth for Kubernetes itself. And so that's not great. There are mechanisms to actually use the Kubernetes auth stuff if you have tokens, where you can take a token and then you can actually use that with Kubernetes. If you're using something like an OIDC provider, you could actually implement your thing as a separate thing and map identities between things. But right now, this is not an uncommon thing. I think kubeless avoids this because kubeless doesn't have its own API server. The way that you program kubeless is that you actually write CRDs, custom resource definitions, essentially resources directly into Kubernetes. You do that with the authentication and the authorization that you have for Kubernetes, which means that like all your path and plumbing for the API server is already set up, combined with the and then you're just reusing the same auth and the same RBAC that you're using for everything else. Yeah, so yeah, and again, I totally hear you, is that like it's very, very difficult to get something that meets the bar for both easy to use for developers, but then also secure by default. And it's really, and I think, you know, there's really some tensions there. And I think it's, if you're not careful, what you can do is you can say, hey, we took all the guardrails off so that people could get started and play with this stuff. But then, you know, oh, when I want to deploy for production, you want to use this totally different way to actually deploy the thing. And I think what we've seen, and a lot of folks have seen this, and is that the way that you deploy for dev and the way that you actually deploy for production, if you have two totally separate things, then either one of them breaks or people take your developer thing and they actually end up using that in production without trying to. And so I don't know if I have good advice for you, but I would say err on the side of being more secure with maybe some scripting around that. Even if you have to do things like self-signed certs, I think, you know, folks understand that. So I'm not going to leave this cluster up for a long time because, you know, anybody can go to openfaaS.tgik.io8080 and start running functions on my cluster. That's probably not a great situation, but I think it is good for getting started. Okay, but let's play with it. Okay, deploy a sample function. So we got the CLI, and then let's see, and then edits. Okay, and then clone. Oh, I have to clone. Oh, let's clone the CLI repo. All right, there's definitely more there. Okay. Okay, we're gonna build a well. Let's make sure that we get the edit samples.yaml and change the gateway. Okay, so you're saying, so Alex, you're saying cloning to grab the samples. Okay, check out the guide to build a serverless Golang function with OpenFaaS. And so morning coffee, learn about the CLI. So there's all sorts of good stuff. It looks like you guys have some good guides here around this stuff. Oh, that's like a blog post. Okay, where is that guide that you're talking about? Oh wait, where I saw something. Golang. It's not on this page. So you said guides. It's probably in a different place. Is it probably that guy? Let's see. These guides are. It's maybe under the FaaS CLI index page for guides. Oh, down here. Oh, I see. So this points off to a whole bunch of stuff. Okay, go. Oh, a go, not okay. Go Python build. There we go. All right, very cool. Oh, and we got a cute gopher. Oh, look at the cute gopher. Okay, so prereqs: Go, OpenFaaS. Let's see. Go is great. We love Go. We're gonna project called struct hash. That's gonna do. It's gonna do this CNF. So we got the CLI. Okay, we're gonna do FaaS new. Okay, so this is interesting. So I'm gonna go to FaaS test. I'm going to work that, and so I can do FaaS CLI. What is it? It's. Please provide a name. Okay. Oh, if one of the languages. Okay. New Lango. Okay, there we go. Okay. Oh, and this will create a folder under this. Okay, so let's. You keep telling me to keep reading, but I like to do it as I go. All right, so what are we doing here? So, wow, so this did, it went through and it grabbed a zip file off of GitHub. So if GitHub's down, we're broken. But that'll never happen. I'm sure it gets cached. And then is going through and expanding a bunch of templates and stuff like that, and cleans up the zip file afterwards. And I think it probably, my guess is that, oh, it has templates for all sorts of stuff, even though we're just doing Go. And then we have this go hash.yaml. Okay, and this thing's assuming I'm at localhost, so obviously I'm not now. So we are at OpenFaaS.tgik.io. Go hash image that. Okay. Okay, so we got that. Now I have a folder called go hash with a handler. Vendor the library. Sure, let's go ahead and, oh, we're doing dep. All right. We got the latest version of dep. I don't think I've updated it in a while, so go ahead and do that. I think I have Go 1.8. Vendoring tool. Dep. Okay, so I can do dep init. Okay, so it gets mad because I'm not in a directory of my Go path. Make dir go export go path equals yeah, we're doing the advanced thing here, so the hello world would be quicker. Sure. So cd go and then we'll go through and we'll run this thing here again. All right. You had an instruction about the go path. Did I miss it? Oh, okay, yeah. Make it under. There we go. Okay, yeah. You guys were way ahead of me. I skipped over that. Okay, but we're pretty much there now. Cd go hash. This is my bad. Oh wait. This doesn't have the same template stuff that the other one did. Why did... So this has go hash.yaml and go hash and all sorts of stuff. Oh, interesting. So this is... Oh, it's in the root directory. Okay. So not everything is in that directory that gets created. Oh, so I have this. Okay. So now we're under functions. Okay. Okay. Got that. So, and I think the question is, why is there a requirement for dev? And I think it's because you're using dep, and dep assumes that you're actually running in a good path. All right, we got to make this bigger because y'all can't see stuff. Well, that's maybe a little bit too big. Okay, so we got to do this. OpenFaaS.tgik.io. And then under go hash, we have handler. There we go. This thing now, vendor the libraries. Okay, so let's go ahead and vendor a dependency. So this actually says go ahead and do that. We did that. Then we're going to do a dep init and then add that. Now the question is, am I going to be doing this in the right? Yeah, I want to do it in the functions directory. Okay. Okay, so if I run dep ensure again, it will disappear because I added it before I used it. And now it says update the handler here. And so this thing is a function and handle, and it takes an array of bytes and then hashes the array of bytes and then goes. Okay. Okay, so I'm supposed to run dep in the go hash directory. Okay, I may have build and deploy cd No, it's building from the current directory. So it has, okay. It's customizable. Golang dev seems harder than setting up a, yeah, Go dependent. There's a sordid history of Go dependency management. It's, it started out so simple and it's gotten so complex. Okay, so he says for this example, we're going to need those deps in that. Okay, so we did the deps in the wrong place because it couldn't find stuff. So let's go through rm. We're going to delete the vendor directory here. And then we're going to go into go hash. And it didn't say, I don't think I missed anything. I think this didn't say I should be doing that from that directory, but we'll go ahead and, oh wait, failed. Oh wait, did I miss something? Oh, it's there too. Oh, I see. Okay, so because it picked it up when we did a dep init. So that'll go through. Okay, that got it. We got struct hash. Now I go this, and now I can go through and I can do build. Now this will go through. So this is actually calling into Docker. Okay. All right, and then you're saying that I'm also going to have to go ahead and do a push because it's a multi-node cluster, which means that I'm going to have to go ahead and push this into a Docker registry, I assume, is what we're actually talking about. So non-root multi-stage build. Okay, so we have an image now. So if I go ahead and run this, my guess is that it's going to fail because the image is not available on the node that I'm actually talking to. Go hash not found, saying, hey, I can't find your image. So, oh wait, no. So we got an accepted to, and then, now does this actually, it says no functions found, and wait, so my UI, it disappeared, it looks like. Well, let's do list. Oh, and it assumes that, okay, so okay, so the deployment's there. Okay, there it shows up, okay. And we can invoke it and stuff, and there's counts, and so we have, and here's the image that we're using, but it can't find that image. So I have to do, okay, so the first thing is that there's no feedback that the image is not running. And so let's do push it to the hub. So if I do push, okay, so now I need to auth. Right? Okay, perhaps you can leverage Docker multi-stage here to build the Go exec and bundle the final Docker image, hence don't have to install Go locally or set path. Yeah, we could do that. Your CLI tells you and calling will give you feedback. Okay, so refers to a repository library Go hash. That's not where we want it to go. So I'm not quite sure. Put our namespace in there. Okay, so does my namespace have to go in this YAML file, the gohash.yaml? Oh, image. Okay, so I guess I want to do jbeta-gohash, right? Would that do it? Yeah, it's the dep thing that actually I think caught you there. Is that dep when you run dep locally, you could run dep inside the thing, but then you want to write the dep results back, and so then you'd have to map the volume in when you do the Docker run. Okay, so let's do a build again because we're going to be building under a different name. It cached everything. We're going to do a push. Let's see. Oh, look at that. That works. Sweet. Okay, now we do a deploy because we've updated the image, so that should actually get its act together now. Okay, error removing. Function name, EOF. So maybe because it was running or something? I don't know. Okay, so when you do an update of this, does it remove the old? Push parallel and build parallel for. Oh, just to make it run faster. All right, so let's see what we got going. Okay, so now we got it. Go hash is running, request body. Hello world. Invoke, we got a 200, and the response body is a hash. Sweet, we hashed some stuff using Go. That's awesome. All right, we're done. We can do a little dance. Oh, and look, other people are hitting it. All right, you guys can all start playing with the cluster. Oh wait, it's like, oh, this is fascinating. It's doing something. It's doing a thing. Oh, and other people, oh, look at that. Matthias was here. Yeah, so this is the problem. Okay, so here's a suggestion on, here's what I would actually have you do for OpenFaaS. Is that you could create a CRD, and what you could do is you could have people write in essentially a password. I'm just trying to think, like at some point we want you to be able to sort of create some equivalency between sort of like what you can do in your Kubernetes cluster and how you authenticate with how you're going to authenticate to your UI and stuff like that. And so I mean, you could have like a token that you do when you first do the deploy, but I would actually make that be dynamic, and I would make it be dynamic with CRD, so that way you can update that stuff. And then the act of writing the CRD is proof that you have some access to do something someplace, right? So that's something to think about there in terms of the way that we could start securing this, so that we don't have Matthias going in and mucking with your cluster all the time. Cool. All right, so let's see what's going on behind the scenes. So we have go hash SHA-SUM. So SHA-SUM is probably, is this what? Oh no, I don't know where SHA-SUM is coming from. FOSNetties D, the alert manager. Okay, so we know most of these things. SHA-SUM is something that somebody else started up on the thing. Yeah, I think, it's definitely going to be a little bit tricky, Alex, to make this work in a generic way. But I think just having the idea that, or at least what we did with Kubernetes is that we made the authentication and authorization stuff pluggable. And so, okay, I'm not seeing any something's going on here. We made it pluggable so that you could actually sort of have, different types of providers that would work. Oh, it looks like maybe somebody went through and deleted all the functions. No, there's still... Somebody's running OMG serverless. Yeah, this is good. Guys, please be nice. I feel like I'm at a conference. I'm going to be like, everybody turn off your cell phone so the Wi-Fi works, right? And so we can do, let's see. So the file here is essentially your config file. Let's see, what do we have? So this, does the CLI work? Because I'm not seeing anything in the UI now. Someone's playing, yeah. Oh man. So now it looks like the thing might be down. So we have this, somebody's money. Is somebody Bitcoin mining? It's borked now. So yeah, so someone's doing some sort of DOS on this stuff. Here's what I'm gonna do. What is my IP? I'm gonna I don't even know what my IP is. We're going to go through. I'm going to lock this puppy down. VPC. Actually, no, this is going to be, yeah, so this will be security groups for this. Then is that one. We have default. Sorry, this is OpenFaaS 2. There we go. Inbound rules 8080 edit. That's why we can't have nice things. Yeah, so the SSH tunnel would be a good way to do this. I think talking about sort of like, here's the command line. If you can SSH to your master, add this stuff to the end of your command line, and you're actually good to go. That'd be sort of one good piece of advice here. Or let's see, Moyer, who's one of the security guys that works here, has a web application firewall where essentially you sort of put some sort of web server in front of it that essentially acts as a, but then you need that to call the functions too, so that's something that's interesting. Okay, so let's go ahead and let's kill some stuff. What did we install any CRDs? No, I don't think we did. So how is this stuff getting stored? I mean, like, where is this? There we go. Okay, so we're going to go ahead and delete the stuff that, okay, so Linux config Bitcoin node. Somebody started Bitcoin mining on us. That's the way it works, man. The minute anybody can run a function, they start Bitcoin mining. So Shasam was just Alpine. So we're going ahead and doing that stuff. So yeah, so I did adjust the security group just for me. So that's the other thing that you can do. With Kubernetes, there's no standard way to actually say, hey, I only want to let traffic in from this sitter range. But there are annotations for different cloud providers. And so the AWS one might have one, I'm not sure. So this thing, I said delete money. It says error, okay. So that thing is still around. I'm not sure why that one's not being deleted. Okay, whoa. Oh, that thing, I went remove, but it removed, okay. So so there's a lot of context. So that YAML file, so this is interesting, and I think it's a little confusing for me, is this YAML file has both the function and the provider in it, right? And so generally, the provider ends up being like, that's like a separate piece of config that you might want to break out into a separate file, right? So I accidentally removed the wrong function. And my function, so F, if I don't do the F, so this is the problem, is that like if I don't do the, okay, gateway equals, so this is weird. So it's saying, it's giving us a 500, but now, okay, it finally got itself. So I'd expect that you wouldn't get a 500 if the thing's not found. That'd be like a 404. Okay. So now we can deploy. Oh. Deployments.extensions, go hash not found. I don't know. Already exists. So I'm getting a lot of 500s here. Okay, so this thing, hello world. No? So I don't know if this is deployed. Okay, so it's not deployed, so the function's listed here. So it's trying to delete it. All right, so this is, this is interesting stuff for sure. I think, piece of feedback, one of the things that would worry me here, and I think that this is something to keep in mind, is that as you're doing I'm going to give it a few minutes to do its thing. As you're doing an update of a function, a couple of things, and this is looking at some of the history with App Engine. Being able to keep multiple versions of that function in flight at the same time, so having an idea of version is very useful, with the idea of like which is the default version, and then being able to address the old versions directly. That's a way, you can do that with a naming convention, but as you start sort of hooking this up to paths, you essentially want a little bit of dynamic routing based on version. And so that's something I'd look at. And then if you do that correctly, then what you can do is, as you're deploying new versions, you don't have to delete the old one first. Because I'm looking at this and it's like, oh, I'm deleting the old one before I'm doing the new one. Well, if you're depending on this, that means that you're doing downtime. And so doing some blue-green deployments there makes a ton of sense. The other interesting thing that it's not clear here. Let's do the deploy again. Give it a chance to settle and get its act together. Thinking it did a delete create, which when you do it twice killed it. Okay, so it's doing some asynchronous stuff there, and when I hit it again, that's what caused things to actually mess up. What I would do is, again, it's like, and this is how we design Kubernetes, think about desired state, right? It's not about create, it's really about make sure that I have one of those and make sure I don't have one of these. And then you can have something in the background where if I update it well, is in the process of actually doing an update, it'll actually eventually come and settle on the thing that it wants to do. Now, the way that I would do that with Docker images, because you have this idea of like mutable last labels when you don't have that, is I would use, assume you're running with a Docker v2 registry, and I would resolve that latest label down to the SHA-SUM, right, as part of your deploy. So as part of your deploy, you want to make sure that, hey, if I scale up, I'm not actually pulling down a new version because I updated latest, right? You should never use latest in production in general, but I think having, being more, so we're still having problems here. So, but having more, sort of being version aware, I think could probably help you out here. Okay, change the name of the function and deploy again. So let's give that a try. So the name of the function, go hash 2, is that the name of the function? No. Oh, go hash here. This is the name of the function. So this is one of those things too, when you're doing YAML vocabularies, and I go back and forth either way on this. There's a school of thought, and I'm definitely sympathetic, which everything to the left of the colon is part of your schema, and so that should be stuff that is not user values, right? Whereas everything to the right of the thing is actually user values. And so one way to do this, if you were going to do this, like if I were designing this, is I might do something like have a list here and then have name. Now, we did this a lot of places in Kubernetes, and it actually creates problems when you're updating it, but it's really clear that that's now the thing that I go ahead and update. The one place where we didn't do this in Kubernetes is things like environment variables when we're designing an API, because those things are so clear and it's so like overwrought to do like name colon foo value equal colon bar. But for stuff like this, I could go either way on that. So, but it was a little bit confusing right off for me to see that, oh, the blue sort of left of the thing is the thing that matters. But let's go ahead and deploy this thing again. Okay, now we're deploying go hash 2. Let's see how that's working. Okay, so the update flag does a rolling update rather than deleting. So update true, replace equals false. Okay, so there is a way to essentially get that thing out there without deleting it. All right, this thing seems like maybe, okay, Let's check the logs. We're going to start debugging here. Something wacky is going on here. Something wacky is. TLS handshake. So I think what probably happened here. Let's do a little bit of debugging. So, all right, so we got Prometheus. That's, I might have had, I think what probably happened here is that the node got marked as failed because somebody started the Bitcoin mining on it. And because that happened, what it did is it probably starved out all the CPU for the kubelet B. I'm using relatively small nodes on this stuff. And so my guess is that that landed on the node that a lot of this stuff was running on. And we'll see if things actually, so this node here, this is why you don't want to open up your stuff to the world, kids. So this node here, gosh, it's always tough to actually figure out what the private IP address. So this is 17.122. So that's what we're talking about here. If I look at the monitoring, now this thing is a teeny tiny T2 medium. So you can definitely, and here we see the CPU utilization actually went through the roof. And what that probably did is starved out the kubelet. And so I can try an SSH in there. Problem is that the SSH daemon is probably whacked. Now the way that Google handles stuff like this in Borgland production is they actually go ahead and run the Borglet, which is the kubelet, the Docker daemon itself, inside of a container that's sort of like configured in a more sort of like lizard brain way. So it's not using Docker, but like using the underlying container technologies. And they give that priority and protection. And so that way you really want to protect a workload that's totally starving the network or the CPU that goes ahead with this. Now what I can do here is I can go through and I can delete this. And the way our QuickStart is set up is that this is an auto-scaling group. When this thing deletes, it'll try and do a graceful delete, and it'll probably take a while because the thing's so wedged. But and then the auto-scaling group will actually come up with a replacement, and that'll stitch itself into the cluster and will actually be up and running again. But what happened is because that node was sick because something took over, Kubernetes noticed it. And let's see. Oh, and okay, it did actually get far enough to maybe deregister itself. I think, is there like an all, show all? Yeah. Okay, so it's already removed from it. So as part of the shutdown sequence, the kubelet gets notified and it gracefully removes itself. Is AWS charging you for running a hello world function? Care to elaborate on the pricing policy for these functions? Yeah, so obviously, like, we're paying for nodes here as part of this. Now, one of the interesting things here is that we can look under the covers and actually see what containers are running, how many instances are running. And so there is an ability to actually sort of like dig a little bit deeper on this stuff. So that thing actually get there. And so Amazon's in the process of shutting this thing down. What we should have here is now all this stuff is now running on a new node. And so if I go through, we can just do open. We can do a deploy. Oh. Go #2 must be a valid DNS entry for service name. Maybe that was not the thing to edit. So let's go through and do this. Already exists. All right, so I think we're good now. Okay. Maybe. Oh, go ahead. Oh, it has to be. You can't use numbers there. Okay. Now I got this 500 because it tried to tear down the old one before it deployed it. And so that's probably, that 500 is a little bit worrisome. Yeah, oh no, internal server error. So we gotta, maybe the thing's still spinning up. Go #2. All right, so that's thing. See, don't deploy twice. It comes out of Kubernetes. We need to handle it. Okay, so try it now. So let's give this thing a second here and see what's happening. It could be that the gateway is wedged also. So let's restart the gateway. I'm not seeing. Yeah, so let's go through and go back, and we're gonna scorch this thing from orbit here. And we're going to do FaaS.yaml, monitoring.yaml, RBAC. Well, we don't need to do the RBAC one. Those things should be up and running now. All right, we have some stuff coming down and some other stuff coming back up. Let's see. So where does OpenFaaS actually store its data? That's one of the things that I'm wondering, because we're not using, we're not using a persistent volume claim anywhere, I don't think, and I don't see like config maps and stuff. So that's something that I'm curious about. All right, so let's see if this thing is back up now. Should be getting its stuff together, hopefully. I wonder why this stuff is taking so long to actually terminate. That's something that's interesting. It's using deployments and services for data. Oh, interesting. So like, I guess just like the deployment itself is actually storing the data of what's happening. That's fascinating. So let's look at, we can, not deployed. All right, so this thing, okay, so we have a label here with the function name that we're doing there, and then we have the deployment version. So that's essentially what's being used, I think, for queuing off this stuff. So I guess you guys go through and you look for all the deployments with FaaS function go #2, and there you go, you're up and running with that. So that's pretty cool. And then yeah, and so let's see, I think we're running out of time. I think I get the idea. So there's some really cool stuff to like here, and I think I just want to summarize sort of what I've gotten here. And believe me, I'm not, you open the stuff up at the world, people are going to abuse it. I think the biggest thing I would be careful of is, having some sort of auth here by default, even if it's like, a randomly generated token that you copy and paste around. That's fine. I mean, this stuff happens, and you open this stuff up to malicious actors, and they're going to find ways to break it a lot of times. So the interesting things here is I like this thing is very Docker image centric, right? So when you deploy a function, it's very much like what you're actually doing is not necessarily like if I go to the console here, where did it go? Wait, error name not resolve. That's weird. So like, the service came down. Oh yeah, okay. So my load balancer came down, so that's why I can't get it. Okay, so when you go to that console, I think what this is in some ways you're deploying a Docker image, and part of a deploy is you actually build and push that Docker image, and so there is no storage of the text of the function someplace. It's actually all bound up in the Docker image. But what you do have is a standard interface for that Docker image and a standard way to build it. And so that's what the OpenFaaS, the FaaS CLI deploy build does, is that it's actually a standard schema for actually building and then deploying these things. In some ways, this feels a little bit like Draft from Microsoft, because it's essentially a schema for how do you actually go ahead and build images and then deploy them in a fairly straightforward way. Now, I think along with this, we didn't get a chance to explore it, but you have the monitoring stuff that you get, which I assume plugs into the gateway a little bit for being able to get that. So that's definitely great. And then Panos was asking, so yeah, definitely would like to look at the Prometheus stuff, because I think once you start getting these standard schemas for what the what the interface to the Docker container is, once you start getting that stuff standardized, then you can do things like assume that you can do auto scaling and monitoring, and I think that becomes a real value add on top of it. So now you don't have to roll that stuff your own, because there's a standard way of doing that stuff. And then there's the question of Panos is asking about function chain. I think function chain is assuming that like you call a function that calls another function and then you get the return. And then I think at some point, it would be good in a little bit. I'm not sure when I can get it on the TGI K schedule to actually do it with a closed cluster. It's not fair when you open this stuff up to the world. So please, everybody, don't read into that. There's definitely, that you're asking for it when you go ahead and do that. I'm pretty sure that that was one of the things I was getting. And then the fact that like I have this like, I got a 500, let me retry it, definitely led to that's just sort of a automatic reaction for me. And I think that was probably making things worse for the system also. So that's definitely something that I'm going to, I need to train myself not to do that. And I think the confusing thing is when I first did a deploy, server returned unexpected 500. And I think it was trying to delete the old one before it returns the new one. So there was some confusion there. So that's actually really, really interesting. Really interesting stuff, though. I think the things that I like about it is that it's very Docker native in terms of that you're building and pushing images. I think that that's a really interesting thing. And when you do that, you can imagine yourself getting really creative about coming up with new ways of doing this. Now, one of the things, and I'd love Alex I'd like Alex to address is, does this support 0 to 1 scaling? Do you handle the case of when a request comes in, you only actually spin things up right then and there? And my guess is no, just because you have to make sure that you have the images pre-pulled, otherwise things get really slow. So that's something that I think is an interesting architectural thing. And then we're using deployments here. When you start doing the auto scaling, are you doing that based on metrics that you're getting from Prometheus manually, or are you tying into to Kubernetes, horizontal pod auto scaling, which is sort of the built-in Kubernetes way of actually doing horizontal auto scaling? So yeah, so 0 scaling, 0 to 1 is in progress. So that's really interesting. That getting that down to something that's 100 milliseconds is a really hard thing, really hard. So that's a lot of work to be able to do that. And so that's definitely interesting. And then a lot of times with these things, you only get the value when you start looking at things like the metrics that you're getting out of it and the other controls. So all in all, really interesting stuff. Let's see, auto scaling works agnostically. So I assume that means that you guys are implementing your own auto scaling based on the metrics that you're getting from Prometheus through the gateway. Is that right? Yeah, okay. So that's my guess there. So you're actually going through and sort of implementing your own auto scaling algorithms. That's fine. I mean, like Kubernetes is flexible enough that it can work either way. And that's why we've decoupled these things, right? So whether you're using the built-in or the sort of official autoscaler, or whether you're doing something yourself, you're operating as peers. So yeah. And again, everybody, please don't read into the fact that somebody ruined our fun by Bitcoin mining. That stuff happens. But I think it does highlight that, I think we saw this with OpenFaaS, and we saw this with same thing with fission. It was open to the world. Now it turns out that we didn't have any bad actors that time, but security in my mind is not something that you can kick the can down the road. Something's not production ready until you actually have some of those security things thought through, or at least have big red flashing warning signs saying here's the right way to use this, here's the place where it'll work and not work. That type of stuff ends up being really critical. So with that, I'm going to sign off. Alex, thank you very much for joining us. I think it was really great to have you along to guide through this. I know not everything goes when it's planned. It never does, right? This is I'm playing with this for the first time. We didn't pre-flight it. It's I know it's a little bit stressful to see somebody playing with your baby. But please don't read too much into that. It's some really interesting stuff that you guys are doing, and I do like all the guides and the blog posts that you have on how to do this stuff with different languages. That's really great too. I think having good documentation, good guides has to be part of the story as you're building systems like this. So very, very cool. So with that, I'm going to go ahead and sign off. Alex is the guy if you have more questions about OpenFaaS. So he's the person to talk to there. Otherwise, I think next week I'm going to go ahead and I'm going to call it now. I'm going to take a look at, not this one, I'm going to be taking a look at Brigade next week, which is I would say this is most similar to the fission workflow stuff that we just touched on last episode. And so I'm going to take a look at Brigade next week. So please tune in. We'll take a look at that. We'll see what ways I can break Brigade and make stupid mistakes. We'll scramble together to try and fix it. So, all right. Thank you, everybody. If you enjoyed this, please, hit the like button, subscribe, tell other people about it, and I'll keep doing these things. But with that, I'm going to sign off. Everybody have a good weekend.